3, 2, 1.
So, as TC says, I'm the director for the Planetary Science Division at NASA. And the main goal of NASA's Planetary program is to explore the solar system to help us answer important questions about how the planets formed and how they evolved. And of course, there's a lot of really special places to go throughout the solar system, but Mars has always held a special place in that exploration. If I could have the first graphic, please. Going back to the Mariner missions, the Mariner flybys, and the Viking landings, Mars has always held that special place up through even our current missions, the current series of orbiters and landers and rovers that are currently operating on the surface today, and of course leading up to Perseverance, which is about to launch. Some of the reasons why we've always found Mars to just be such a special place and so fascinating: for one, it's relatively accessible. It's relatively close in the solar system. We can get there. We can arrive in a matter of about 6 to 7 months. So that's relatively short on the planetary exploration timescale. But in addition, it also holds a lot of really unique scientific value, particularly for trying to understand planets with rocky surfaces and planets with atmospheres, helping us understand how they form and evolve and help us better understand our own history on Earth. Mars preserves on its surface some incredibly complex and diverse geology. On Earth, of course, our crust is constantly recycled, weathered and eroded, and so it's very hard to find places that have preserved that history from billions of years ago. And yet on Mars, we can find places where we see that full breadth of history preserved on the surface. It also, of course, is a planet with an atmosphere. It has a climate, just like Earth has a climate. And much like Earth, the climate on Mars has changed over time. And so by understanding when and how that climate has changed helped us better understand our own climate evolution on Earth. It's also a place where, on the surface, since it's so old, it's preserved. We've also understood that in the last about 20 years, we've come to better understand that the surface of Mars was actually probably much warmer and wetter in the past with a denser atmosphere, and that perhaps several billion years ago, life could have possibly taken form on Mars as well, similar as it did on Earth. And by going back to Mars, we might be able to find evidence of when life could have taken place or could have taken hold on Mars. This is a study of astrobiology, of understanding the environments that could support life and understanding if and when life can actually come to be. And Mars 2020 Perseverance is in fact our first mission from NASA that's specifically designed to answer these astrobiology questions on Mars. And if I could have the next graphic, please. But everyone will tell you that this is an incredibly complex mission, but they didn't do it alone. All of those that worked on this mission are leaning on the legacy of all those rovers that have come before, from Sojourner to Spirit and Opportunity to Curiosity and now to Perseverance. We're building on that legacy of what's come before, but Perseverance is also laying the groundwork for what comes next. You're going to hear a lot today about the incredible science that Perseverance is going to do on the surface of Mars and about its main goal, which is to collect some samples to bring back to Earth in the future. And our next big mission, of course, is going to be Mars Sample Return, where we plan to execute the first ever round trip to Mars and execute the first ever launch from the surface of another planet. And that whole mission will be focused on trying to bring those samples, those very precious samples, back to Earth where we can analyze them here with our incredibly capable laboratories here on Earth. And all of this is also then leading towards potential human exploration in the coming decades. We've got specific technologies on the Perseverance rover that you'll hear about that are also going to be talking about, that will be demonstrating these core capabilities that we're going to need in order to support human exploration in those coming decades. And I wanted to just give a plug real quick for two more press conferences that will be held tomorrow afternoon for both the technologies and for Mars Sample Return if you want to learn more about those two things as well.